So today we're going to talk about the rock lab, igneous sedimentary metamorphic rock lab. You have several questions related to the readings above, and for igneous I would like to point out that igneous rocks are based on where they're formed. Okay, so if I have my volcano, here is the inside and here is the exit. And I say it like that because inside is called intrusive and the exit is called extrusive. Okay, extrusive rocks tend to be small crystals and they form really fast. They're explosive. Inside you can have bigger crystals, okay, and they form really slow. They have more time to form from the magma inside. Sedimentary rocks are classified by the way they're formed, okay, and the biggest type is clastic. Clastic, when seen on the reference table, it even says fragmental, which means that it's made of many fragments, like many pieces of sand or many pieces of silt, or a combination of rocks. Then the article goes on to talk about metamorphic rocks. Metamorphic rocks are rocks that formed from other rocks. It's just that maybe they had a lot of heat or a lot of pressure or both that changed them. And they are classified also by their texture, but specifically whether or not they're foliated. Foliated means that the minerals have aligned. So here I have a stack of papers. There's many layers, but they're sometimes a little hard to see, okay? Another specific type of foliation is called banding, which is very obvious. It's a series of dark, light, dark, light, dark layers, or sort of layers within a rock. Okay, so now we're going to identify 3 igneous, 3 sedimentary, 3 metamorphic. The first one is a picture. So for igneous, I'm given vesicular, which is this rock. Okay, it has a lot of holes, and I can very clearly see that. It seems like something came exploding out of it that created all of these holes inside of it. And this texture is called vesicular. Now, when we look at the igneous rock chart, it's split into a few different ways. One way is to split the rocks like this. Okay, and when I split them like this, I come up with extrusive rocks and intrusive rocks. I can also split this chart this way. Okay, and when I do it this way, everything to the right has a darker color, higher density, and is more mafic. Everything to the left is lighter in color, lower density, and more felsic. Now, a rock like pegmatite, it contains these minerals. Okay, so the only mineral that pegmatite, granite, rhyolite, pumice, obsidian do not have is pyroxene and olivine. But they do have a little bit of amboy, a little bit of biotite, etc. So now for our vesicular rock. Let's see. We know the texture because I've given it to you. I specifically said it's vesicular. So under textures, we have glassy, vesicular, fine, coarse, and very coarse. Those are the important ones, okay? Because if I say, oh, it's non-vesicular, well, then that could be any of these other rocks except for this row. But now that we know the texture is vesicular, I'm going to check that off, okay? That the crystal size is non-crystalline. It is vesicular, which is considered a type of glassiness, and its color. Now, when I look at this, I see brown, which to me is more of a dark color. So I'm going to say that this is dark. Now, once I've said that something's either light or dark, I'm going to go straight across because remember, when I had this chart before, I said that if everything was on the right side, that means color, density, composition are all going to be the same. Okay, so if I have a darker color, that means I'm going to have higher density, more mafic. Higher mafic. Environment of formation. Well, if I have a vesicular rock, I come across and I see that I'm here on the top of the chart, which makes it extrusive. Remember how I said you could go like this with the chart, okay, and everything on the top is considered extrusive, whereas everything on the bottom is intrusive. So this is an extrusive rock. What does it include? What is it made of? It's made, well, we said that it was darker, which means that it's on the right side of the reference table, which means it's made of everything except for potassium feldspar and quartz. Those are the only two that are not within a rock that's from this side of the chart. So I'm going to check off everything except for quartz and potassium feldspar. I'll check off everything else. And now I need to figure out what rock is that. Well, if I've said it's darker and I've said that it's vesicular, where do those things match? Well, they match right here under something called scoria. That's the name of this rock. You've just identified it. How did you identify it? By looking at the texture. So this is scoria. And that's all you have to do to identify these rocks, is use the picture or look at the way that it's classified. Now, like I said, for sedimentary, again, it's classified or organized by the texture. All of these on top are clastic. And they even provide you symbols that kind of represent the rock. Okay, the only black sedimentary rock is coal. On the bottom, we have metamorphic. And this chart is split in the middle as well. And it's based on, surprise, surprise, texture. Whether it's foliated or non-foliated. Okay, and foliated is those layers or mineral alignment. And then we also have banding, which is those light and dark layers. And then it includes some comments and what's it made of and the type of metamorphism. And then it tells you, what was it made from? What was the pre-existing rock? Okay, so like for example, let me do quartzite. Quartzite was made from sandstone. All right. Okay, guys and girls, good luck with the lab. Send me a text if you have any questions.